Welcome everyone to where we are putting together solutions for those math and science topics that we are getting problems with. Today, we will be looking at the topic of factorization in mathematics and some of its many different methods. This is our first video in this mini-series, so feel free to like the video and add comments in the description down below, or post which topic that you may need help in, so we can make a video for you. A little revision here that we must make sure that we're very good at multiplying or dividing two terms. If the terms have the same signs, then we will have an addition. If the terms have different signs, like a positive and a negative, then the answer will be negative. If we have more than two terms, we work with two terms alone, find the solution, and then continue with the third term. We are having a get-together for the neighborhood children, and we have 15 puzzles and 10 toys to distribute evenly among them. There were 5 children who came to the party: Sherry, Christina, Harvey, Samantha, and Bobby. So our job is to work out exactly how many puzzles and toys each one of them gets. In the first method, we put the 15 puzzles and 10 toys together and form 5 groups. And as we distribute the square red puzzles one at a time into each blue group, we then do the same for the green circle toys. We can see that each one of the groups gets 3 puzzles because there were 15 puzzles in all, and there were 10 toys, with each person getting 2 toys. In the second method, we will look at the 15 puzzles and the 10 toys to be divided into 5 packages. So we will take it and divide them individually. 5 into 15 puzzles are 3 puzzles, and the 5 into 10 toys are 2 toys. Thus, 5 packages each has 3 puzzles and 2 toys. So this is a different method of getting the same solution. It may be a little quicker because we don't have to actually draw out all the items. This method informs us of 2 things. 1, what is the largest amount of exact packages that can be made? And 2, how many of each item forms a package? Remember, we have 15 puzzles and 10 toys to be divided. So the first step will be to find the largest or highest common factor. Breaking up the 15 puzzles will give us 3 times 5 times puzzles, and 10 circles will be 2 times 5 circles. Since 5 is the same in both of them, then the HCF is 5, and this tells us that the most amount of equal packages that we can make is 5. Now that we have the HCF, we can write it as follows. 15 puzzles would be 5 times 3 puzzles, where 5 is the HCF and 3 puzzles is the unused remainder from this line. We now do the same for the 10 toys, which will be 5 times 2 toys. Therefore, we can have 5 equal packages at 3 puzzles and 2 toys each. In hindsight, this method provides us with more information than the others. So we shall be concentrating on any method that gives us these 2 pieces of information. Let us now attempt a second example using method 3. But let us note that this method is commonly known as factorization. So, we have 18 red x's squared plus 24x to be shared or grouped. So step 1 entails finding the highest common factor, HCF. We can take the 18x squared and break it up into its smallest prime factors. So it will be 2 times 3 which is 6, times 3, which is 18, by x, which would give us 18x squared, plus 24x would be 2 times 2, that's 4, times 2, that's 8, times 3, which is 24, times x. Let us see what is the same in both of them. There is a 2 and a 3 and an x. So therefore, the highest common factor, HCF, is 2 times 3 times x, which is 6x. Now that we know this, we can move on to step 2. This is where we are going to separate each one of them. We can write it as follows. 18x squared will become 6x, which is the HCF, times 3x. Let's double check it. 6 times 3 is 18, and x times x is 18x squared, plus 6x times 4, which gives us 24x. Thus, we have completed it. And how do we know we have completed it? We have completed it because what is inside the brackets cannot be broken up or factorized anymore. In this method, we repeat step 1 of finding the HCF. When we have completed it, we now apply it to the area of a rectangle. Since the area of a rectangle is length times breadth, we take one side to be the HCF, which in this case is 6x. Since we know the area of the first rectangle is 18x squared, and one side is 6x, then the other side is 3x. Similarly, for the second rectangle, the area is 24x, and one of its sides is 6x. So the other side is 4. Thus, we have factorized the expression using the area of rectangles. We shall now proceed with factorizing of 3 terms. So let's look at the question here. 12 triangle squared plus 8 triangle window minus 24 circle triangle window. We try to use these shapes rather than letters, which may confuse some of us. Now, step 1 would be to take all of the students and find the highest common factor. We begin with the 12 triangle square. Remember, we will be using prime numbers. This will be 2 times 2, 4, 4 times 3, 12, by triangle by triangle. Similarly, for the second term, it will be 2 times 2, 4, times 2 is 8, times triangle times window. And for the next one, it will be 2 by 2, which is 4, by 2, which is 8, by 3, which is 24, by circle, by triangle, by window. So now we look for what is the same in all 3 terms, not just 2, but all 3. There is a 2 in all 3 terms, and we have another 2, but there is no other number. But if we look for a shape, it can't be windows because windows are only in 2 of them. However, we have triangles in all 3. Therefore, the HCF will be 2 times 2 times the triangle, which is 4 triangles. We have now completed step 1. And let us proceed with step 2, where we write the question over. 12 triangles squared, and so on and so forth. And we start to break it up using the HCF times some other factor. So the triangle squared will be a product of 4 triangles by 3 triangles. And we can find that if we look at the working up above,
when we took out 4 triangles, what was left was 3 triangles. So, and we can double check it. 4 3s are 12, and the triangle times triangle is triangle squared. For the second term, we start with the HCF again, and then we multiply by 2, which is 8, and window. Then for the last one, HCF again, where 4 times 6 is 24, and then circle window. Now that we have gotten that, if we look in all 3 terms, what do we have that is the same? We have the HCF. We can extract that outside of the brackets, and then everything else will be put into one set of brackets. We have completed the factorization of 3 terms. Let's take a quick recap. We found the highest common factor, and then we broke up each of the terms. We then pulled out the 4 triangles, and whatever was left was put into our brackets. Be careful with the last one, since there's a minus sign on the outside. So there's minus 6 window. We will now solve the last example using the area method. Each method is acceptable, and it is up to the student to use whichever they prefer. So we repeat step 1 of finding the HCF. When we have completed it, we now apply it to the area of 3 rectangles, as we have 3 terms. Since the area of a rectangle is length times breadth, we take one side to be the HCF. Since we know the area of the first rectangle is 12 triangles squared, and one side is 4 triangles, then the other side is 3 triangles. Similarly, for the second rectangle, the area is 8 triangle window, and one of its sides is 4 triangle. Thus, the other side is plus 2 window. And for the third triangle, since we have 3 terms, the area is minus 24 circle triangle window, and one of its sides is 4 triangle. Thus, the other side is minus 6 circle window. So, we have factorized the expression using the area of 3 rectangles, as there are 3 terms. We now have an exercise to factorize these following questions, some of which have 2 terms and others have 3 terms. Remember to use your steps 1 to find the HCF, and then step 2 to substitute using the HCF and breaking up each of the terms into smaller parts in order to complete your factorization. Please stop your video and attempt all these questions. When you are finished, restart your video and we go on to the next slide where the solutions are presented. The solutions are given as follows, with the last 2 questions having 3 terms in it. If you are still getting problems in any particular question, put it in the comments and we shall send the solutions for you. Thank you for joining us with our part 1 video. And feel free to hit the link and go on to the second part of the series, where we will be looking at factorizing of 4 terms, as well as quadratic equations. Don't forget to add in the comments if you need any help in any particular topic, so we can create a video for you. And don't forget to subscribe. Bye.